Hey everybody, welcome to our first day of probability. So today we're going to go over some basic definitions of probability and do a couple of examples. Probability is everywhere. It's really all around us, and it's all based on chance behavior. So if you think about it, you and your friend might play rock, paper, scissors to see who gets to get the last piece of cake. Football games, they always start off with a coin toss to see who gets to receive the ball first. And of course, you probably know people who try to play the lottery and hit the big bucks to win millions of dollars. Not necessarily a good idea. But basically what we're going to do is talk about what is probability and how to calculate it. Probability is all the mathematics of chance. And it's basically describing outcomes over a long time. Probability is calculated as a number, and it can be anywhere from 0 to 1. If the probability of an event is 0, that means it just can't happen. It's not possible. If the probability equals 1, that means it always happens, every single time. So if it can't occur, it would have a probability of 0. If it happens every single time, it has a probability of 1. And usually it's somewhere in between. So if it happens half the time, then you'd get a probability of 1/2 or 0.5. You can write your probability answer as a fraction, as a decimal, or as a percent. And you'll see it in all different forms throughout this lesson. So 3 things that are important to keep in mind with probability. First of all, it's talking about the long run behavior. So a lot of times things appear like they're not predictable in the short term, but if we observe things happening over and over and over and over again, a pattern emerges and we can calculate the probability over the long term. For example, if you flip a coin, you know that you flip it one time, it's either going to be heads or tails. So you have 2 outcomes, and our chance of flipping heads is 1/2. However, if we flip a coin 10 times, that doesn't necessarily imply that we will get exactly 5 heads. If we do it over and over and over and over the long term, then approximately half of all of our coin flips would end up being heads. So that's the difference between what we call experimental outcomes, what we're observing in the short term, and theoretical outcomes, which is what we're calculating based on long-term probabilities. And what we're doing in this class is all about theoretical outcomes. Also, you want to keep in mind what the word random means. So a lot of people think the word random means haphazard. Like, I'm just going to go talk to that random girl over there, meaning I don't know who that is. And that's not what we mean here. So what we mean is that the behavior is simply due to chance alone. So anytime you see random, that means that there's a chance process involved. So to calculate the probability of an event occurring, we need to figure out how likely it is that it could occur. So first you need to know how many total items there are, and then how many of the item that you're interested in. For example, if you have a jar full of marbles, you need to know, if you're interested in selecting a red marble, how many red marbles are in the jar out of the total marbles in the jar. And of course it gets a little bit more complicated than that, but basically it all comes down to this one formula: the number of ways the event can happen divided by the total number of outcomes. So let's review some basic probability that you already know how to do. So the first would be just tossing a coin. So when a coin is tossed, there are 2 possible outcomes: heads and tails. So the probability of the coin landing on heads would be 1 outcome out of the total of 2. So 1 out of 2 is 0.5. Or the coin landing on tails would also be 1 out of 2, or 0.5. Another common probability problem involves rolling a die. A single die versus a pair of dice or multiple dice. So obviously it gets more complicated the more dice you involve in the problem. But if you're just talking about throwing a single die, assuming it's fair, that means that there are 6 sides to a die with 6 numbers, 1 through 6. So if you roll a die, the probability of any of the 1 numbers being face up would be 1 out of 6. So if I wanted to find the probability of rolling a 2, it'd be 1 out of 6. Probability of rolling a 3, 1 out of 6. Probability of rolling a 6, still 1 out of 6. And then of course we're going to get into more complicated problems, which might be, well, what's the probability of rolling an even number? Well, for that, you have to look at which ones are my even numbers. So I'd have 2, and I'd have 4, and I'd have 6. So then just count those up. 1, 2, 3, 3 out of 6 would be 1/2. And so as we get more complicated, we'll progress with more details like that. So before we go any further, let's just stop for a second and take a little checkpoint. So try this. So you're going to match one of the probabilities with each of the statements below. So we're giving you these probabilities right here, whoop, right there, and then match those to these statements. So A, the outcome is impossible, meaning it can never happen. B, the outcome is certain, it will happen every single time. C, the outcome is very unlikely, but it can occur once in a long sequence of trials. And D, the outcome will occur more often than not. So I'm guessing you're doing pretty well with A through C. And then D, maybe we need to stop and think about that one. So here we go with the answers. So for A, the outcome's impossible, it can never occur. I bet you got 0. Bet you got that one right. In fact, I'm about 100% sure that you probably got that right. So B, the outcome is certain. It will occur on every single trial. That's 1. And if we write that as 100%, as a percent, we would say it's 100% likely. In other words, it will happen every single time. C, we're looking for the outcome that's very unlikely, but it still could happen. So that would be 0.01, which means that that happens about 1% of the time. And you see probability like that with, say, drugs that have side effects, things like that. You hear that reported on commercials all the time with the disclaimers, about 1 in 100 or 1%. And then last one is a little bit more confusing. So the outcome will occur more often than not. So basically, you should have chosen 0.6. So that is going to be more than 0.5 because it happens a majority of the time, or more than half. So you had 2 options you could choose from, 0.6 or 0.99. So the best answer is going to be 0.6 because that's 60% of the time, which is definitely more often than not, but not almost all the time, which would be basically what 0.99 would represent. So that would be about 99% of the time, which means almost every single time. And just based on the wording of the question, the 0.6 or 60% would be a better answer. So as we get into the probability problems, you'll see lots of problems that have the words or and and. And basically these 2 words, you should have light bulbs going off and flashing in your head when you see these words because they tell you exactly how you want to approach the problem. So if a problem has the word or in it, they're talking about the union of 2 events. Or is very inclusive. You can be this and or that, and we'll take anybody. Anybody can join our club as long as you have this and or that. So when you see an or problem in your head, always think it could be this or that, or it could be both of them. You just have to have either one of those options to be part of the club. And problems are much more exclusive. involves the intersection of two events. So for an and problem, both characteristics have to be true. So when you see an and problem, you want to think it has to be both this and that. So here's another example. We'll stop and let you give this one a try. So here's some or versus and problems. So you have a spinner here with 8 equal spaces, so equal chance of landing on any of those spots, numbered 1 through 8. 2 of the spaces obviously are purple, 2 are yellow, 3 are blue, and 1 is red. So for every probability problem that we're dealing with, we're talking about the probability after one spin or one selection. In this case, one spin of the spinner. So if you spin the spinner one time, what is the probability that the spinner lands on purple? Or number 2, purple or yellow. Number 3 would be an even number. 4 would be an even number or the red spot. And 5 would be an even number and the red spot. So I'll give you a few seconds to think about those. Okay, so let's see how you did. So the probability of spinning that spinner one time and having it land on a purple spot, but you got that. We have 2 out of 8 are purple. So for your answer, you'd want to simplify that as a fraction and get 1/4, which is also equal to 0.25. If you give your answer as a decimal, in this case, it works out to be an exact answer, 0.25. But if you need to round your answer, in other words, if it has many more decimal places than just 2 decimal places, we want you to round it to 2 decimal places. The probability of getting purple or yellow, there are 2 spots that are purple, 2 spots that are yellow, so that makes 4 out of 8. So 1/2 or 0.5. Okay, how about an even number? 2, 4, 6, 8. So there's 4 even numbers out of 8. So again, that probability is 0.5. So what about number 4, an even number or a red number? So I have 2, 4, 6, 8. Those are my even numbers. Or red. Well, red is 7. That's an odd number. But remember, in this case, since it's an or problem, I'm going to be very inclusive here. So I'm going to get anybody who has either an even number or they're on a red spot gets to come to the party. So in this case, I have 5 options out of 8, which is, as a decimal, is 0.625. So 0.625 is an exact answer. You could round that to 0.63, and that would be correct as well. And then number 5, an even number and red. Well, now with this and here, now we're talking about being exclusive. So it has to be both even and a red spot. And I only have this little guy over here, that's my only red spot, and it's an odd number. So the probability of that is just 0. Can't happen. So the next 2 sets of vocabulary words that show up a lot with probability are mutually exclusive events versus overlapping events. So mutually exclusive, sometimes you'll hear them called disjoint events. It means that 2 things can't happen at exactly the same time. If it's one thing, it cannot be the other. They're mutually exclusive. They can't happen together. Overlapping events mean that you can have both things at exactly the same time. And one does not mean that you can't have the other. You can have both. So when you're trying to decide if an event or a combination of events is mutually exclusive or overlapping, the way I tell my students to handle these problems is to take all the objects, whatever it is, even if it's students, which shows up a lot in problems, take all the students, throw them into a box, shake up the box, Then you're going to select one student out of the box, or one item, whatever it is you're looking for. Can that one item you select have both of the things you're looking for at exactly the same time? So you're reaching in the box, pulling out one thing, can it have both? If you can have both, then the events are overlapping. If you cannot have both, if it can only be one or the other, then we say that those events are mutually exclusive. Okay, your turn again. Try this. So decide if these events below are mutually exclusive or overlapping. So you're going to spin the spinner one time and decide, can these two things happen at the same time? Or if you get one thing, does that tell you that the other item can't happen? So number one, even number and a purple space. Number two, the spinner lands on an even number and a red space. Number three, the spinner lands on a red space and a yellow space. And four, a multiple of 3 and a blue space. So I'll give you some time to think about that. Okay, so time's up. Let's see how we did. So for the first one, even number and purple. Yes, you can get an even number that is purple. You could land on number 8. So that works. You can have both events could happen at the same time if you land on number 8. So those are considered overlapping. On number 2, even number and red, again, we're back to that same red 7. So 7's not an even number. So if you know you land on red, you can't have an even number. And if you know you get an even number, then you know you can't be on red. So those are mutually exclusive. They can't happen at the same time. Number 3, red space and yellow space. Nope, those are mutually exclusive. You don't have anything that's striped or polka dotted or anything with both of those colors. So you know it has to be one or the other. It can't be both. That's mutually exclusive. And 4, multiple of 3 and a blue space. Well, what about number 6? That's a multiple of 3 and it's a blue space. So those are overlap. I hope that helps give a brief introduction to probability. Be sure to check out the next video where we walk through 4 examples that will be very similar to your homework problem and are a little bit more complicated than what we covered here. Thanks and have a great day.